Good day everybody. Again this question, let me write the question down. Let a differentiable function satisfy f of x is positive, f of x positive, integral 9 to x f of t over t times dt is equal to root of x with x being greater than or equal to 9. We are expected to find 64 times f of 16 is equal to what? Okay, so let's get the solution. Now what I wish to do is I will consider f of x positive, integral 9 to x f of t over t times dt is equal to root of x. I differentiate, I get f dash of x positive f of t over, in fact this is going to be f of x over x is equal to, when you differentiate this you get 1 over 2 times x raised to the power of 1 over 2 negative 1. So this is rewritten as f dash of x positive f of x over x is equal to 1 over 2 times root of x. Now let me set f of x is equal to y. This would give me f dash of x positive y over x is equal to 1 over 2 times root of x. This is a linear differential equation. So therefore we have the integrating factor as e raised to the power of integral p dx, where my p is 1 over x. So therefore integral of p dx is equal to integral of dx over x, which is nothing but ln x. So this means e raised to the power of integral p dx is equal to e raised to the power of integral p dx is already known, right? So what I will do, I will convert this to e and place the value of ln x. So e raised to the power of ln x will give us x. So therefore the general solution is going to be y times x is equal to integral x times, now what have we got? We have got 2 times root of x times dx plus arbitrary constant c. I can rewrite this as y times x is equal to 1 over 2 times. Now x is root of x multiplied with the root of x, right? So root of x and root of x can be cancelled, giving me root of x dx positive arbitrary constant c. Now if you were to integrate this, y times x is equal to 1 over 2, you get x raised to the power of 3 over 2 divided by 3 over 2. So the 2 can be flipped there. So 2 gets cancelled, giving me y times x is equal to x raised to the power of 3 over 2 divided by 3 positive c. Now we are expected to get the value for f of 16. Okay. Now to get the value of f of 16, we have to get rid of this constant. Now the condition we are going to utilize is x is equal to 9. So what I will do is I will consider f of x positive integral 9 to x f of t divided by t dt is equal to root of x. Now for x is equal to 9, you find the functional value. So f of 9, this will be equal to 0 because we are setting x is equal to 9. So it's equal to root of 9, which means f of 9 is equal to 3. So when x is equal to 9, the y value is equal to 3. So therefore the general solution which we got here, y times x is equal to x raised to the power of 3 over 2. X raised to the power of 3 over 2 divided by 3, right? Divided by 3 positive c becomes, so what does it become? When x is equal to 9, y is equal to 3, perfect, and x is equal to 9. This I want to write it as 1 over 2 raised to the power of 3. it's acceptable, right? A raised to the power of n times m can be rewritten as a raised to the power of m, the whole raised to the power of n, or a raised to the power of n, the whole raised to the power of n. This is from the law of indices. So this is by the law, okay, by the mathematical law, and divided by 3 positive c. Now root of 9 is going to give me 3. 3 raised to the power of 3 divided by 9 positive c. You have 9 times 3 is 27. So this is already 27 and you have a 3 here, right? So 3 divides 27 9 times. So 9 positive c, you have 27 here. So therefore c is equal to 27 negative 9. So what is that? Let me check. From 27 you take away 9. What do you get? You get 18. So therefore the value of c is equal to 18. Now c is 18. So let me go to the next page. So therefore what we can do? So therefore we have, so what do we have? We have y times x is equal to x raised to the power of 3 over 2 divided by 3 positive 18. But we need to get the functional value. So y is equal to 1 over x times x raised to the power of 3 over 2 divided by 3 positive 18. So f of 16 is needed. So for x is equal to 16, this is 1 over 16 times 16 raised to the power of 3 over 2. See, this is 3 over 2. I'm going to write 3 over 2 as 1 over 2 raised to the power of 3 divided by 3 positive 18. So this is what we have got. So this is going to be 1 over 16 times root of 16 is 4. So this is 4 raised to the power of 3 divided by 3 positive 18. Okay, so this is what you've got. So now you have 1 over 16. Now 4 raised to the power of 3 is what? 16 times 4. So this is 64 over 3 positive 18. Which is going to be 1 over 16, 3 can be taken as LCM, so 64 positive, 8 3s are 24, 2 and a 5 there. So this is 1 over 16 and you add these two together, you get 8 and 118 divided by 3. But this is my f of 16 value, but we need 64 times f of 16. Which is equal to 64 times of f of 16 is what? F of 16 is 1 over 16 of 118 divided by 3. Right? 16 times 4 is what? 6 4s are 24, 2 4s over 5, 6, 64. So this divides how many times? 4 times. So 4 times of 118 divided by 3. Which is equal to 8 4s are 32, 3, 4 1s are 4 and 7 and 4 and 3. This is what you got. Can I divide 472 by, I don't think so. Because you get 17, 15, 22, not possible. So this is the right place for us to stop. So this is the solution. 472 divided by 3 is the value that we got for 64 times f of 16. So that's a beautiful question. Please like, share and subscribe. Thank you everybody.